the concept of time. The I want to just come back to the idea that it is single dimensional. Now, it moves from the past to the future, from blooming, from young girls to older people. And it is only the second law of thermodynamics, known to physicists as the reason for entropy in strict balance disorder, which supports the concept of the arrow of time. And it signifies a certain, shall we call, asymmetry of the direction of time. It goes only one way. So the entire universe is acquiring more and more entropy, more disorder as it gets older. Self-organizing processes such as living things and galaxies and things like that, they are in somewhat peculiar situation because they advance towards complexity and at the same generate entropy as a byproduct. What I mean by that is the stars are created, energy is being emitted, stars change shape, galaxies change shape, and stars themselves go through a number of processes until they exhaust their fuel. You know that very well. All that generates heat and all kinds of radiation, which is byproduct of that. As a result of that, the quality of the energy that was initially available to change the quantum state is now not available to do that kind of work. It is lost in heat and other radiation, known as entropy. Okay, I'll move on with that. Commonly, time is defined as something that we measure with clocks. What we really mean by that, it's a factor of motion, of change of state. If you are standing and you sit down, then you've changed your state. Or processes, as in aging, or any chemical processes, or nuclear. Einstein proposed that the faster an object moves, the more time appears to slow. Time doesn't actually slow down. There's another term in physics that I won't go too much into. Time simply dilates, but you can take it to the bank that the faster you travel in a rocket, the slower your biological processes, the slower all the chemical and other process within the rocket. And as you approach the speed of light, time almost stops. Now, this happens also very close to large body of mass, such as black holes. An observer watching an astronaut falling into a black hole would see the person to go fast towards the black hole at first, and then slow down, become smaller, slow down, and as it approaches the edge, known as the event horizon of the black hole, it would appear to stop, go redder, and disappear. Of course, the astronaut wouldn't disappear. It would go through the event horizon and go into the interior of the black hole. So, depending upon which observer you are referring to, they see different things. And Einstein named that concept relativity. If all motion stops, then time will also stop, and also clocks. Time will never really stop, ever. There will always be quantum vibrations because it cannot achieve absolute zero temperature. Okay, moving on then. Speaking of clocks, at the top left, we have the first ever dial, sundial that was constructed. Apparently, it comes from China. It somehow found itself into the empire of Assyria. And then when Assyrians were at war with the Egyptians and the Egyptians won, they transported it to Egypt. So henceforth, it became known as the Egyptian sundial because it was discovered in the sands over there. And here we have a number of different samples of sundials. One thing about sundials is they are very reliable, except not accurate. And of course, if it's cloudy, then nothing happens. No time. Okay. Um, Here are some other examples. The one at the left is favored by monks. I haven't really seen any use of the water clock, but I still use the one on the right to cook my eggs. Uh, from that, we progressed significantly in the Middle Ages when the pendulum clock was discovered, based on the concept of oscillation. Just to the right, you have a diagram of how this works. There is a weight suspended, and the spring, which transfers the energy by one click of the ratchet, discharges that energy. So it needs to be wound on again. That was a great invention, except it works very well when the clock is still. One of the biggest problems, diagram on the left at the bottom now, was for naval vessels, particularly war vessels. There was no way of accurately estimating where they are on the globe. I mean, approximately they knew by stars, but they needed an accurate measurement of time to be able to tell what time of the day it is, and hence they work out, or night, and hence work out the angle. Now, Admiralty of Great Britain proposed an award for the first person that comes up with a good solution. And in today's money, that would be worth several million. This was won by one fellow called Harrison, and the clock that you are looking at now could go forward, sideways, and forwards and up and down at the time. And never did it miss a beat. It was a huge success. So from then on, naval vessels all use that kind of concept. In the middle, you have the famous Prague clock from Czech Republic. You probably know more as astronomers about it than I do, but all I know is that it shows seasons and cuckoo and come out, and they make noises, and signs come out, and all kinds of crazy things happen. And I just thought I'd include that for entertainment. On the right hand side, we have what's known as a 10,000 years clock. It is purely mechanical, and it is said to be accurate to 1 second in 10,000 years. It was recently constructed at great cost. I don't know why would ever anyone bother to do that. But of course, it's been available for about 10, 15 years. So no judgment on how accurate it is just yet. Right. We also have atomic clocks. Atoms vibrate in a cyclical way, and they are considered as oscillators, and their energy is measured to the nth degree over here, as you can see in the middle number of zeros there. But all clocks, no matter whether they are pendulum or wristwatches or sundials or even atomic clock, suffer from the same problem. They have to be stationary. As soon as they start moving, they experience the Einsteinian prediction of time slowing down. Okay. Now, let's talk about modern view of time. Time is a concept that is not really fundamental. It is not a fundamental entity in physics. It has no actual existence in physicality. It's a man-made concept. It's like money. Money in itself is worth nothing. It's a piece of paper. It's a promissory note that when you spend it, The buyer has faith that if they take it to the bank will honor it because it's guaranteed by the government. And it's only the concept of time is only useful as a mathematical way of measuring events and processes. And in equations, we differentiate variables with respect to time. Some of this might come as a surprise to you because our intelligence and our concept of time is based on classical concepts. I should also explain here that when you grow up and you acquire full faculties of intelligence at the age of 11, by that time the brain has developed a model of the external world, and the words and the concepts that we use to communicate with each other are part of that. Your mum would have taught you much of that, and then you learn things in school from books and so on. And then the brain builds a model of itself. I am who I am, and I communicate with the external world, taking input through my senses and through power of speech and other behavior. So this is what I mean by events. Every change, everything that you do, every change of state, whether it's classical or quantum, is known as an event. So this is what is meant by measuring the events. Most quantum physicists now agree that time is not a fundamental entity, and the flow of time is only an illusion. What they do agree on is that the processes of the exchange of energy, which is capable to do work at certain level, to the level where that energy is expended and cannot do the same work at that level, but is now extended in terms of heat and other radiation. This is now considered to be the reality. So time in physics is suggested by other people as an emergent entity from subsystems, such as entanglement or entropy. Once again, we won't dive into that. And as a result of that, the concept of reality, either in a classical sense or quantum sense, is constructed by a series of events, change, now moments, which are composed by our mind into some kind of a continuity, like a strip of film. Let me take you to the movies for a moment. You may recall that in the olden days, we had um, a long strip of film wound on a roll, and the projector would start the projectionist, and you sitting in the audience would see people riding horses, people walking, people talking, people having a cup of coffee, and you build up a continuity, a sense of time passage. But in essence, nothing has happened like that. The slides on the movie have not changed. It is clearly a psychological illusion. The time has passed. At the Planck's level, which represents the slowest tick of time, which is 1 over 44 zeros of a second, and space, which is a volume of space known as quanta, which is 1 over 99 zeros um, of a centimeter cube, um, level, at the Planck level, both space and time completely lose their identities. There is no, they don't mean anything anymore. This is where Einsteinian theory fails, at the Big Bang and at the center of the black hole. And the quantum theory does not do any of that. What it really means that we do not have physics which address these solutions, what is time, what is space, at high levels of energy. Psychologists consider time as a fantasy that we need to cling to. We know that time passes because the sun travels across the sky. You pick up your children, you go to work, you come back, have a drink with the boys, you go back and pick up your children. Sometimes you watch a cricket match on the television, time has passed, but it is an illusion. You're going to probably find it a little difficult to accept at times. I'll read you a little poem here, which was written in the Roman days. And likewise, time itself cannot exist, but from the flight of things we get the sense of time. Now then, we must confess, feels time itself, but only knows of time from flight of rest of things. So time consists of series of nows. You live in the present. The devil of it is that by the time you become aware of the present, some time has passed. What it really means that we always live in the past. We never seriously experience real time in the present. We cannot live in the present, contrary to the teachings of Buddha. So time flexes in the presence of mass, as in a star, galaxy, or a black hole, and when you accelerate or travel at high velocity. The concept of the universe itself changed a lot during the recent history in the last 300 years. Newton regarded universe as a clock. A supernatural being created it, wound it on, and let it run. And time for Newton was the same on Uranus, on Andromeda, as it is in Sydney, and it progressed at the same time. Einstein changed all that and completely destroyed that idea. It is not so much that Newton was wrong about many things. He simply produced an approximate matter in the way that he understood. The biggest problem for Newton was the concept of gravity. He never understood that, and he said that he will leave the research on gravity to the future generations. And that is the major difference between his view and Einsteinian view. In the 20th century, in the information age, we considered universe as a giant computer which computes in the imaginary ones and zeros, um, change in states, in processes. When something rotates from left to right, it changes its state from left to right. When it flips upside down, it changes its state. This changes the information about the entity itself. And so we consider universe as a processor of information. That's just another way of viewing things. Max Tegmark, one of the cosmologists, suggests that the universe is a mathematical model running according to predetermined mathematical rules and laws, physical laws, and everything is hunky-dory so long that they obey these mathematical laws. Personally, and I'm joined by majority of mathematicians and physicists, I think that is not right. To my mind, something existed before the universe from which universe was born. Nothing comes from nothing. There was a famous philosopher in the ancient Greece who said that only nothing comes from nothing. So if there is something, there must have been something from which it came, or words to that effect. It kind of loses in translation from ancient Greek to English. And so when we come to consider time um, and laws, these are products of human mind. Laws were created as a result of observations, either periodic or or unscheduled. Certain patterns were observed, and then we wrote a suggestion. At first, a hypothesis, which then became proved in various observations, and then it became a physical law. And now we have laws. But in actual fact, nature doesn't need any laws. It does what nature does. And our description of it is what I call laws of physics and the mathematical models we structure. One of the problems with mathematicians and physicists is they construct models in mathematical language. And sometimes they are so obsessed with mathematical correctness that they forget that the physical reality has been left behind. This is become a serious problem in studies of models. A fellow by name of Saskind and a Dutch researcher by name of de Hooft, uh, both Nobel winners, consider that our universe is a hologram, as shown on the right-hand side. Um, the idea is that information is stored on a flat surface of the universe. The universe is so large that you consider its edge potentially being as flat, and it projects inwards and into the universe, and this is why we see everything in 3 dimensions. I don't know how true this is, but that's the current kind of thinking. Likewise, this kind of concept came from the study of black hole. The surface of a black hole is known to store the information, quantum information of all the matter that fell into it, and then um, it projects inwards um, for the information to be 3 dimensional. Once again, it's a subject for a whole hour of discussion there, so I'll leave it for the moment. The one thing I haven't mentioned are the two diagrams in the middle. The ones with ones and zeros represents either a body such as a universe or a body such as a black hole with information mathematically stored in ones and zeros. How it is actually stored, no one knows. Possibly by polarization of photons, or potentially by some magnetic fields at Planck's level, which are tiny, but mathematically they are represented by ones and zeros. The picture of a block on the middle right represents a mathematician's way of reading hours. At the bottom, you have 3 factorial, which represents 3 by 2 multiplied by 1, which is 6. At the top, you have a cube of 1728, which happens to be either 12 or 24. I haven't worked it out. Okay, so I'll leave that idea here. I have another nice little poem for you, written by a priest by name of Angelus. Time is of your own making. It ticks in your. Its clock ticks in your head. The moment you stop thought, your time stops dead. So that was a very forward idea in the 1500s for saying for things like that. People used to get burned on the on the pyre. The diagram, rather the painting by Salvatore Dali, reflects a change of thinking in art, both in sculpture and in paintings, after Einstein published his theory of relativity. People started thinking about the inconstants, the varying nature of both time and of space, and he painted here the persistence of memory. That's the name of the painting. That we remember our past, we remember our experiences, but we cannot remember the now moment because it's already in the past. We cannot remember the future because it has not yet happened. As we move through individual now moments and events, they've been already relegated to the past, but the brain reconstructs them as if though they were happening in the present. It happens so fast that you think you are living in the present. And when you are seeing things changing, you think they're changing now. In fact, they're changing in the past because it took the brain time to construct the story from its senses. All right. I want to introduce you to a different idea now. The concept of wormhole. Einstein did not call them wormhole, but Einstein and Rosen wrote a joint paper about something that was known as an Einstein-Rosen bridge. At the top left, you have such a picture, which apparently can join by a tunnel known as a wormhole. They called it bridge. Two black holes which are entangled, and because of that, certain information can pass between them. And the construction of the wormhole is a very difficult idea. I won't go into that, but you've probably seen various science fiction movies where people, the Enterprise ship, um, directed by Spock and others, they go through wormholes. This is absolute fantasy. Nothing like that will be possible for a long, long time. The life form would be disintegrated in that process. Okay. There's another concept known as the paradox of time. It was considered that Einstein could have gone into the future and visited himself at his desk, seen a paper on relativity which he has written, and come back and present it as a given fact. Now, this is very nice. Another person who didn't like his father would like to go back and kill his grandfather, so the father wouldn't come about. Now, does that mean that there are two of you with the gun, one that kills your grandfather and one in the now that it has happened? You see what I mean by the paradox? It cannot happen, because if the grandfather died, then all its offsprings would not have been born. Hence the paradox. However, at the bottom line, I've listed a concept known as retrocausality. This is something very new in physics. Apparently, now this is only a theory, not even a theory, because it's not testable very much. More of a hypothesis, a projection, a conjecture, if you like. The idea is that the future communicates with the present, and it influences, that it's a one part of continuum. And I will show you a diagram in the next slides how that happens. And apparently, because the future and the present is entangled together, it is one part of the same system. Therefore, it influences what happens now. So time travel might just be possible if this theory is right. It'll explain many issues. The spooky action at a distance that Einstein was so afraid of, the concept of gravity acting at a distance that Newton couldn't explain, and all kinds of concept of entanglement of two distant particles or entities that are far away, and yet they act as one system and they react at the same time. These things will all be solved by this concept of retrocausality. Let's not proceed any further with that. Okay, a monk by name of St. Augustine suggested that time came into the existence with our universe, with the Big Bang. What he really said, the words he used, was that the universe came in time. Sorry, with time, not in time. If it came in time, it would have meant that time existed before and the universe came in that time. But because it came with time, our time is now measured from the moment of creation of the universe. How it is created is a subject of another talk. But from time zero, the sort of hypothetical time zero, our time progressed from that moment on. And other models suggest that time continues from one cycle to the next. Our universe expands, contracts, expands, contracts, um, and at the end of each cycle, it might bounce or regenerate, and so on. So time continues, the external time, so to speak, continues, in which case we could very well be experiencing the cycles in global time or multiverse time. Now, Roger Penrose, famous physicist, mathematician, and Hawking was his student. He came up with a concept of conformal cyclic cosmology, where when all stars burn out, and all matter has been devoured by black holes, and then the black holes radiated it out as black photons. These photons can coalesce together. They are quite happy to live in squillions of them on the pin. However, you can the theory of quantum physics says that you can only compress so many of them together, and as they come together, they create enormous pressure, and then shockwave occurs, and they rebound, and we have another Big Bang. This is the concept of conformal cyclic cosmology proposed by Penrose. At the moment, it hasn't cottoned on as yet. So, spreadsheet. A score sheet of time. At the left, we have an argument, time is for real. In the middle, it's an illusion. At the right-hand side, it's emergent. So people who argue that time is real suggest that the arrow to time is irreversible, and that proves that time exists and is fundamental. Leibniz, on the other hand, mathematician and philosopher of the 18th century, suggested that time is defined only as a relationship between events. Remember, event is defined as a change in processes. Quantum physicists say that time emerges from entropy, entanglement, or a theory of loop quantum gravity. This is something that has been proposed by Carlo Rovelli. Okay, back to real. Particles, subatomic particles known as kaons, when they interact, they travel back in time. What that really means, you have a little diagram on the right-hand side here. Two kaons come in from the left. They interact. They don't actually crash into each other. Nothing in nature ever makes contact. If you think that when you push a billiard ball with a cue, you think that the cue and the ball make contact. That is not true. Nothing ever makes contact. Electromagnetic forces between the two prevent it. So what happens here is that the kaon travels, becomes an anti-kaon, and goes back and becomes a kaon again. So it travels back in time, so to speak. But that process takes a certain amount of time. So other people argue that that is not so. The quantum mechanics argue for the illusion of time in the middle here. And they say that you can see a block here with a red slider. This is known as the Einstein's block time. Apparently, everything that has happened in the universe and will ever happen again is already there. It's already been written. And we simply travel through the now moments like a slider. Like every person that is born, the slider starts at zero and slides through the events of his or her life. And this is known as a block time. The argument for some support for that concept is that there is no time involved here. We simply go through series of changes, series of events. The detractors of that say that in such a universe, nothing ever changes. There's no change, and we know that universe changes. So Okay, next one. Time is treated as continuity, variable, varying in relativity theory. However, the standard model of particle physics does not even list time as a phantom entity or as a given priority. Time to the physicists in quantum mechanics is not necessary. It's just a byproduct, a convenience, shall we say. In mathematics, time in emergent concept is used as a convenience to study the rate of change with respect to time. It can be either discrete or continuous, but not fundamental. And I should mention here that neither time nor space is actually discrete. It is continuous, and every effort to make it discrete or quantize it, as physicists call it, has failed. But for some sake of simplicity and the ease of calculations, physicists and mathematicians treat time and space as quantized or discrete. Time is also perceived by humans as continuous and flowing from past to the future. Psychologists say that it is an illusion. All we really do is observe change, and when the change ends, all time stops. So the time concept of time emerges as a byproduct of psychological biases inherited in our childhood. We can see that the sun moves, we can see that stars move, that people move, and past events become the past. So that's the score sheet. In a way of summary, Newton's time was the same everywhere and everywhen, and time appears us to have a unidirectional continuity, and hence the arrow of time, the continuous flow. But what it really is that the change in the quality of energy, which causes change, produces byproducts such as entropy and disorder, heat, radiation, and so on. Clocks measure time and give us a sense of the cause and effect, which there is now no explanation in terms of causality. Quantum physicists deny the existence of time as fundamental entity. Rather, they argue that it emerges from other things. Quantum gravity has not been invented, but this is the holy grail of physics. In the block time, which I mentioned just before, all events in the past, present, and future already exist, and the now moment slider simply moves through your lifetime as a sequence of changes. Psychologists consider that time is an illusion made by the brain, and it manufactures this as a byproduct of, uh, of sensual um, input, reconstructed by persistence of memory. Time travel is mathematically possible and offers paradoxes, and time is considered as a succession of events of motion. And when motion stops, time stops as well. And that is the end of my talk. And if you, Andrew, if you could terminate that now.
Thank you
Hello, can you hear
for
me?
that. Yes, I'm here.
Yeah. Can I end this session now?
No, don't do that just yet, because we did have a question.
Yes, but I mean, end the presentation, the slides.
Oh, yeah, you can end that. Yeah, turn that off.
I don't want to
No
say
problem.
you can turn it off.
No, it's
I'll
okay.
just I'll just minimize everything and
That's fine.
go back to the session. Here we are.
Brilliant.
Okay. Now, I hope that this has given everyone time to there's the concept of time to think
Yep.
up some good questions. I'm happy for you to disagree with what I've said, have a
Yep.
different idea, supportive idea, whatever.
No
Over
worries.
to you.
So, so we did have one question from Marco, which I'm now showing on screen, but I'll read it out. How can something be created out of nothing?
Okay, this concept of nothing is much misaligned in popular literature. A fellow by name of Krauss a physicist, wrote a book, Universe from Nothing, and that has done more harm than anything. When physicists speak of nothing, they mean primordial energy. Primordial energy in which all kinds of changes of some quantum state of that energy in some locality have occurred. And to give you a very quick summary of a 1.5 lecture, imagine that you are in the middle of the sea on a boat and mountains of water are rising up and down, no waves. You are in the middle of the storm, okay? And then all is quiet. You are now in the eye of the storm. Boltzmann, who proposed the second law of thermodynamics, suggests that it is necessary for such a quantum state for a phase change to occur in the primordial energy of vacuum from which our universe has occurred. Now, this might sound like science fiction to you, but this is what's known as a standard model of cosmology. It is not a theory. It's not testable. It is. You can call it science fiction and navel gazing, but we don't have a better theory. And then a quantum fluctuation in that vicinity of the area where the quietness has occurred creates a bubble of energy which expands with the speed of light and then with hyperspeed and creates our universe. The rest is a subject for how the Big Bang progresses. So that's basically the explanation. So the short answer, there is no such thing as nothing. The universe was created from primordial energy, and that brings in the concept of multiverse. If it occurred once to create our universe, then it might have occurred again and again and again, creating many different universes. Yeah, I hope that Matt gives you that gives you some kind of a vague idea. Yeah.
I've just showed the next question, but I'll read it aloud. Can you speak to a finding from cognitive scientists that our intention is not founded by us, but rather we're informed of our intention as our body interacts with the world in real time on its own? Some say it's up to 7 seconds after our actions that we're informed of our intent to perform those actions.
Right. Marcus probably, Stuart has probably his own theory, which he suggested to me once before. I'm not really qualified to comment on that theory, so I won't do that right now. However, you've asked two questions, one of which is the delay. I wouldn't say that it takes 7 seconds. It probably takes much faster. If you touch your water jug that is very hot, it takes a lot faster than 7 seconds for you to draw your hand back. The brain has processed the input and withdraws it. However, when we are watching slower motion events, different processes, it might take longer. If we are experiencing something that we don't understand, it might take us longer to process the idea of what is happening here. So that time of microseconds to 7 seconds, I don't know where that came from, of the cognitive concept is very variable. And can you just flash the question again? I've forgotten the second part of it.
Yeah, sure.
I can't see.
Yeah, that's good.
So I'll read it. Our intention is founded on, yeah, right.
Yeah.
So we now have this takes a concept of consciousness. What is it about us that we become aware of things? Now, this is a long topic, and much debate is on the issue. No one can give you a proper definition of consciousness, but there are some approximations, and I'll offer it to you. Consciousness has certain different levels. At the bottom level, it is known as awareness. Fish are aware of predators, and so are monkeys, and so are zebras, and so on. Some animals, such as dolphins and octopi, have a higher level of awareness, but humans are apparently a level of awareness which is known as self-awareness. Some of it has been observed in octopi and also in monkeys, but not to a great degree, and porpoises or porpoise. So the concept of consciousness now goes like this. Cognitive scientists have many different definitions of it, and when you come to the very bottom level of it, the entire nervous system is an integrated consciousness system. The two lobes of the brain are surrounded by a cortex which stores our memory and houses the processes of consciousness. There is no particular area where consciousness resides. It is written everywhere, sort of like multiple disks in a RAID system on a computer. However, because the brain processes things extremely fast and sometimes slowly, they started studying that idea, and they came with an idea of little, if I can call them pipes, don't use the word, this is my term for time being, and these pipes are in parallel, and some of them are specialized, and they process it very, very quickly and feed it up to the next level of awareness, and next level, and next level, and next level. By the time it comes to the cortex, it is a total picture. So when you touch the hot iron like that, and you react, many thousands, millions probably, processes have taken place and been integrated and fed up to your level of awareness, and so. A completely separate issue is that of self-consciousness. A philosopher by name of Descartes argued, I know that I exist because I have real thoughts. However, he considered the concept of mind as a separate entity from the brain. This philosophy was known as a concept of dualism. Modern philosophers and student researchers of cognition deny that. It is all one. When you die, your consciousness dies with you, regardless of what people believe, supernatural or otherwise. And the concept of cognition is based on human capability to experience sensual interaction. What I mean by that we experience taste, we experience texture, we experience beauty of the landscape, we experience pleasure of kind words, things like that. And these sensual experiences, the cognoscenti have named qualia. Some denied the need for qualia, but it has cottoned on, and it still is present in many different philosophical discussions. So when you experience something, anger or pleasure, or something is nice to touch, or something is nice, like a good meal, these sensations are called qualia. And only some animals are capable of that. You might say that when the whale swallowed Jonah, he should have spat him out because it didn't taste very good. It's possible that the whale didn't have qualia, so it didn't spit him out. Okay, that's as best as I can explain it.
Very good. I think that's all the questions we had for Bruno. Thank you very much again for another wonderful presentation.
Does that mean that everyone understood everything? Or does it mean that everyone was asleep through the presentation?
Yes.
I'm being jovial.
Stuart says, thank you, food for thought.
Thank you very much.
No problem. Thank you again, Bruno.
Thank you very much. Okay.
All right.
So you wish to progress with your part of the meeting now?
I will.
Okay.
All right. So next up is Bill Stent, the telescope gent.
Hello.
Essential guide to the night sky for the coming weeks. Hello, Bill.
Hello. How are you going, Andrew?
Good, good.
It's excellent.
Learning as we go and hosting a live stream, but I think I'm getting there.
Yeah, I'm kind of in a similar situation. I'm just trying to figure out how to share the screen. I think that's how I do it.
Great. Yep, I've got it.
Have you got me
there? We go. All right.
Excellent.
I'll get out of your way.
Well, thank you very much. Hello, everybody. It's time for my normal monthly chat. Late March to early April, what's in the sky? Let's see. There we go. First of all, this presentation is being held on the lands of the Bunyarong and the Wurundjeri Woi-wurrung peoples of the Kulin Nation. I wish to acknowledge them as the traditional owners, and I'd also like to pay my respects to their elders, past and present, and Aboriginal elders of other communities who may be watching this presentation today. My usual structure is that I start off with general conditions, then I go into the what's in the sky, the moon, planets, the orientation of the constellations of bright stars, and then suggestions for the night and this month. And this week I'm going to talk about a little bit more detail about the crosses area, because that's the right time of the month, the year, sorry. Then I'll go into the photographic stuff. And for the early risers, there's not an awful lot going on. Finally finish up with the things to look at for this month. Okay. General conditions. Now, this is my wavy graph as usual. This is one's solar declination. So we're coming up to the equinox this month. That's the 21st or the 22nd of March. This is the time when the nights are lengthening the fastest, because Pythagoras might have been keen on triangles, but Kepler preferred elliptical sine waves. Okay, nights are getting cooler and damper now, so maybe it's time to think about dew control. That's a hydrogen alpha photograph I took a little while ago. Underneath there somewhere is a running chicken, and also Elon Musk, as you probably noticed. But that's what happens when you allow dew to build up on your objective. So that's not a good idea. So go and get yourself some dew control. Okay, so sunset tonight was at 7:46. Nautical twilight ends at 8:43, which is that's also gone, I think. Tomorrow morning, the sun will rise at 7:14, and nautical twilight starts at 6:17. So you should be well packed up by then. Next month, sunrise is at 6:43. So as you can see, it's moving quite quickly, and sunset is just before 6. So for younger astronomers, what happens at the equinox? Why are day and night the same length when they're different at other times of the year? Have a play around with a globe and a torch in a dark room and simulate what's going on. And if you're clever, you'll notice that the photograph I spent quite a lot of time of is clearly wrong. So maybe you can explain that to me as well. Okay, for the moon people, Wusterhövle, that's a cheese grater actually. More wavy lines. Okay, so the moon over the next few weeks, the last quarter and the week following the last quarter. Tonight's actually the last quarter. It's probably up about now. It's deep in the south this week. I don't know if you can see my mouse, but deep in the south means down there. So that's the lunar declination. So deep in the south, that means it's going to be for us in the southern hemisphere. It's very high in the sky, but it will be moving lower over the week. Last quarter rises at midnight, sets at noon, so you can see it in the morning. So yeah, you'll see it tomorrow morning when I'm walking the dogs. Over the following week, it will be a waning crescent, which will get thinner and harder to see as it gets closer to the sun. New moon is on the 19th, so that's the second little week there. It'll be a few days after that. You'll see it as a waxing crescent after midnight, so you have to look west. It crosses to the north on the 19th, so just a little bit before that. So by the time you'll see it, see that waxing crescent, it'll be taking a lower arc through the sky. That's an arc bending towards the north. So the first quarter is on the 26th of March, which rises at noon and sets at midnight. So that's viewable in the evening. And over the week following, it'll be waxing gibbous, so it'll get fatter and fatter, and it starts deep in the north, which means that it's going to be it'll be getting higher. Sorry, I think that means lower over the week. That's a typo. Full moon is on 2nd of April. It's closer to the apogee than a perigee. That's the orange line on that map, the lunar distance. It's more super than average. I don't know what you'd call that. A meh moon. I don't know. It crosses the south on the 1st, so it'll be getting higher in the sky. And over the following week, it'll be getting setting early in the morning as waning gibbous. Now, there's the last quarter on Friday, the 10th of April. That's after our next meeting, so I'm prevented from mentioning it. I can't talk about that. Incidentally, the equinox is on the 21st, so that's the light blue line that crosses the equator on the 21st. Okay, so planets. Mercury is a morning object. It's very close to the sun. It's going to move out of the twilight very quickly, and it's going to have its maximum elongation on the 4th of April. That's actually the best time for viewing Mercury for the whole of this year. So 4th of April, I think from memory, it's 28 degrees from the moon, from the sun. So it'll be up quite a long time before the sun. So if you want to see Mercury, the 4th of April is a brilliant time to see it. You have to watch out in the morning, though. Venus is still an evening object. It sets before the end of the twilight. It's going to be really, really good later on in the year, so you're just going to be patient. It's going to hang around in the twilight for the next couple of months. Mars is also a morning object. It's rising in the twilight as Venus does. It'll very slowly move out of that twilight over this month, and it's going to start to become visible later this month. It will slowly rise over the rest the next I don't know, 6 or 7 months. It doesn't have an opposition this year. It'll have its opposition next year. Jupiter is well past opposition now, meaning it's rising during the day. In fact, I can see it at my window. It sets about 2 a.m. You're getting close to the last chance for a really good view, because as it gets lower, you'll be looking through more and more atmosphere. So if you want a really good view of Jupiter, get on your bike now. Saturn is getting very close to the sun. It's having its conjunction on the 25th this month. It sets just before 8:30. So in practice, it's out of viewing area. It's in twilight. So Saturn's pretty much gone. Uranus is visible in the early evening, setting at about 10:45. Still close to the Pleiades. It's just a little bit lighter, a bit higher. Sorry. Neptune. It's with Saturn, very close to the sun. Its conjunction is on the 22nd, which is a couple of days before Saturn's conjunction. These two are going to stay close for most of this year. Pluto is now a morning object, and it rises soon after 3 a.m. Okay. So get orientated. Okay, our 3 major signpost constellations, normally only two are visible at any one time, and currently that is the case. So we've got, as our clock, that centers on the South Celestial Pole. I was up at LMDSS the other day pointing this out to a friend. You can draw a big circle, more or less, between the pointers, through the top of the cross, through Canopus and Achernar, and that's the big circle which centers on the South Celestial Pole. It's actually a very good way of finding the pole. It's more or less halfway between Alpha Centauri and Achernar, just a little bit on the Alpha Centauri side. Anyway, so there's the clock. And there is a Southern Cross, one of our signpost constellations. It's at about 10 o'clock on that clock at the moment. And that means that the crosses area is now in absolute prime viewing position. So I'll be talking about that shortly. Get rid of that clock. Orion, our other signpost constellation, it's up, but it's well past the meridian now. It's starting to sink in the west, which means that if you want to have a good look at Orion and Sigma Orionis and all those things that are in Orion, you'd better get up to LMDSS as soon as possible. Scorpius is obviously still below the horizon. It's up later on tonight. So the major stars, the ones that we sort of find from those constellations, Canopus leads the cross as always. This is the way I describe it to friends. It's out of the donut hole now, so it's suitably away from the zenith. Achernar, it leads Canopus, or possibly opposite the pointers, and it's getting low in the southwest. All of these stars are circumpolar. They don't actually dip below the horizon. However, Achernar comes pretty damn close. It's probably behind trees at some time of the year. Sirius, very, very bright star. It's only 8 point something or other light years away, so of course it's bright. That's now past the meridian. It was pretty much on the meridian last month. So that's going past, and it's getting swimming towards the west. Procyon, it follows Betelgeuse just past the meridian. It's more or less on about the same declination, just a little bit into the north. So it follows Betelgeuse. Aldebaran, you hop over Orion from Sirius. That's getting quite low in the northwest, but you can still tell that it's an orangey sort of a scar, a little bit like Betelgeuse. Don't get them mixed up. Regulus, which is the main of the line, it's getting higher in the northeast, and it's pretty much on its own in the sky there. It's actually not very far from M44, I think, from memory. Spica is starting to rise in the east. It's probably still a little bit difficult to see. It's probably getting out of the trees a little bit later on. This is at 10 p.m. And obviously, Jupiter is bright, and it's now past the meridian. It's not a star. Try not to use it as a guide. Okay. So visual evening targets for this morning, for this month. This is again 10 p.m. facing south. Okay. Obviously, you're going to start with Jupiter. Sigma Orionis, if you're looking for something in Orion, there's a lot of things going on in Orion, but yes, it's a nice little multiple system. I probably told you before, it's the one that lights the hydrogen alpha the hydrogen behind the Horsehead Nebula. Beta Monocerotis, which is a triple, it's halfway between Betelgeuse and Sirius. M41 is the little beehive. It's quite nice to look at through a pair of binoculars. That's an open cluster. M44, the beehive itself, is out in the middle of nowhere. So that's quite large and very obvious from LMDSS to the naked eye. Castor, if you're looking for a double, it's just past the meridian. Castor's a good double, so it's quite easy to find because it sort of hangs around with Pollux. M47 is an open cluster. Open clusters are always worth watching. Algorab Delta Corvi is a wide optical. It's an optical double. That is, it is not actually a double system. They don't actually interact. One of them is well behind the other. In fact, I think it's a long way behind the other. This is something which I haven't seen before. Apparently, it's a very tight double, so you might have trouble separating it. I don't even know how it's pronounced. Somebody will tell me it's Algeba or something like that. Gamma Leonis, anyway. So, they're just some evening targets for visual people. Now, okay, it's crosses time of the year. Crosses as the crosses, that is the Southern Cross, the Diamond Cross, and the False Cross. They're all in this part of the Milky Way, and they are just rotating up, and they're getting close to straddling the meridian at this point. So it's a great time to see them. I see all the bits and pieces. Okay, I won't spend too much time on this, but there are the three crosses. Moving from left to right, this obviously, I was about to say the one true cross. Let's say the Southern Cross. Then the one in the middle is a diamond cross. It's a lot less crooked than the other ones, and it's sort of more of a kite shape. And the false cross is the one on the canopus end of that particular bunch. Okay, so there's a bunch of open clusters in there. I won't name them because there's a lot of them, but yes, it's a particularly rich area for open clusters. There are also a bunch of doubles or multiples in this case. Rigor, I think, is a triple. I'm not sure about that one. I'm double guessing myself. Nebulas, there's a lot of nebulas in there as well. The dark doodad is one of my favorites. The running chicken is also there. Tarantula is not quite in the crosses areas, but it's in that picture. So there you go. I put it in. And there's other bits and pieces too. There's a globular, there's a planetary nebula, and there's a galaxy in there as well. So there's something for everyone. So it's a particularly rich area of the sky. Okay. Photographic targets. These are the photographs I've very badly stolen from ASV members via Facebook, or possibly not. This is a remote school dome. Actually, it's Herschel's ray. It's NGC 2736. It's coming into perfect viewing place at the moment. That was taken at the time of the full moon, so it's not the world's best photograph, but it was okay. This is Michael Prinzi's 2997. 2997 it's almost a small version of M83. So it's a lovely, what do they call it, grand spiral. Statue of Liberty from Gerald is one of the only, in my opinion, nebulas that actually looks like what it's supposed to look like, what it's what it's named. Running Chicken, something from Nick Stefanik. Stick Stefanik. That's interesting. Sorry, Nick. Sam's Dark Doodad. I have actually shown that photograph before. I haven't got a new version of the Dark Doodad, so someone's going to take one for me. Sombrero Galaxy, Anne-Marie McComb. Hello, Anne-Marie, if you're listening. Lovely photograph. Centaurus A. It's another remote dome photograph. That's the little galaxy that was in the crosses area. And here's M83. It's possibly a little bit early for M83 at the moment. You have to wait until it's sort of, I don't know, 30 degrees above the horizon before you can get a really good go at it. So that's a couple of hours. Also, Michael Prinzi, he's taken two spiral galaxies photographs in this shot today. Okay, last one is Jeff Healy's Mermaid Nebula, ESO 21725. That's really hard to find. It's extremely dim. It's oxygen and mostly, it's hydrogen, but mostly oxygen. It's not very far from the cross, and I've put its RA and deck up there because it's really hard to find. So somebody can go and take some more photographs of it. It's lovely. Okay, 5 a.m. That's for the early risers. I'll give you a hint. There's not an awful lot going on up there. Okay, so the cross is just past the meridian. Get rid of that. There you go. The cross is just past the meridian. Orion has gone, but Scorpius is getting high in the east. So of course tomorrow you're going to have trouble finding Scorpius because there's a dirty great moon in front of it. But, I'm sure it'll move away at some stage. There aren't any planets. Well, Pluto's a planet. Okay. Random observations. Jupiter is stationary tonight. Its retrograde ends. I'm sure that some astrology will have something to say about that, but I don't. Couple of days away, Gippsland Star Party. So if you're going to that, have a good time. The Messier Star Party is next weekend up at LMDSS. 21st on the same day, is the equinox. Day after, Neptune goes behind the sun. That's its conjunction and becomes a morning object. Saturn does the same thing 3 days later. It also becomes a morning object. Remember, Mercury's greatest elongation. It's going to be a great view in the morning if you want to see Mercury. Sadly, or possibly happily, daylight savings ends on the 5th of April. So there you go. All right.
Thank you, Bill. Another great presentation.
No worries. There we go. I think you can see nothing. Well, you can see a photo.
A photograph of you, yes.
It doesn't talk very well.
Brilliant. Well, yes, as Bill mentioned, we've got the Messier Star Party coming up on the 21st. So if you haven't got your tickets yet, make sure you do. Thanks everyone for coming on tonight. Next month we'll be back in person at Mueller Hall and online because there's been a lot of works at Mueller Hall over the last couple of months. Special thanks to Bruno and Bill. But for now, I hope to see you all again next month. Good night and clear skies.
See ya.
See ya.